Hi, in this video I'll give you an example of partial fraction expansion with complex conjugate poles in control system. So this is just an example of partial fraction expansion with complex conjugate poles. This is an example question in which the transfer function given is 1 by s plus 2 into s square plus s plus 1. Question കാണുമ്പോൾ തന്നെ നമുക്കറിയാം how can you expand this using partial fractions. But transfer function can be written as a by s plus 2 plus bs plus c by s square plus s plus 1. This is a general format of representing the transfer function for complex conjugate poles in partial fraction expansion. ഇനി നമുക്കിതിൻ്റെ expansion and how we are going to find the values for these we will see. By partial fraction expansion, this can be written as 1 by s plus 2 into s square plus s plus 1 is equal to the partial fraction form can be written here, a by s plus 2 plus bs plus c by s square plus s plus 1. So this is how you represent it in partial fraction expansion. Now how can you, we are going to find the value of a. So what is the value of a? A is equal to, is obtained by multiplying t of s with s plus 2, right? That is how we have the general equation, and letting s is equal to minus 2. So you have going to multiply t of s with I mean s plus 2. So it is equal to t of s or transfer function into s plus 2. And what should be the value of s be? It should be s is equal to minus 2. Okay, and now when you substitute the values here, what will be the equation? Let us see. Transfer function is given by, it is already given as the transfer function is equal to 1 by s plus 2 into s square plus s plus 1, and it should be multiplied with s plus 2, right? S plus 2, and what should be the value be? S is equal to minus 2 ആയിരിക്കണം. So you substitute these values, s plus 2 cancel ആയി. ഈ എസിൻ്റെ വാല്യൂ ഇവിടെ കൊടുത്തു. It is 1 by minus 2 the whole square plus minus 2 plus 1, or what is the value? 1 by 4 minus 2 plus 1, or it is and 3. So we got the value of a as 3. Now we found out the value of a to be 1 by 3. I'm sorry, 1 by 3. Now we got to find the remaining values, that is b and c. In order to find b and c, what we have to do is cross multiply the following equation, what is given, that is the transfer function, and substitute the value of a, and then equate the powers, I mean like powers of s. അപ്പം ഇവിടെ എന്താ ചെയ്യേണ്ടത് നോക്കിക്കേ. Again write down the equation. ഈ ഒരു ഇക്വേഷനിൽ നിന്ന് നമ്മൾ എയുടെ വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു. So what is it? 1 by s plus 2 this is 2 into s square plus s plus 1 is equal to You have written this equation once more, so you can substitute the value a as 1 by 3 into s plus 2 plus bs plus c by s square plus s plus 1. Now we will see what is the value for this equation. This can be expanded as s square plus s plus 1 is equal to let 1 by 3 be written in the numerator into you take the LCM. So this is 1 by 3 into s square plus s plus 1 plus bs plus c into, you're going to take the LCM here also, into s plus 2 by the denominator as such, s plus 2 into s square plus s plus 1. So you can cancel both the denominators. So what is the answer? 1 is equal to 1 by 3 s square plus 1 by 3 s plus 1 by 3, and then distribute the remaining bs plus c into s plus 2. So it is bs square plus 2bs plus cs plus 2c. Now what you can do to find out the remaining value is you have to equate the powers, equate the like powers of s. This is the main point. You're going to equate the like powers of s, the like powers of s. This is very important. So you when you equate the like powers of s, what happens is we will see what happens. You have to join, bring together the like powers. So s square can be brought together, that is 1 by 3 plus which else is a s square term, it is b, right? And then bring together the s terms, that is s into 1 by 3 plus 2b plus c, again the constant terms, that is 1 by 3 plus 2c. So you have this equation where you have 1 by 3 plus b, which is equal to, you're going to bring the like terms together, right? So 1 by 3, you don't have anything with a square term here. So what happens is you can put 1 by 3 plus b is equal to 0. That means b is equal to minus 1 by 3. So that is how you find out the value of b. We have found out b is equal to minus 1 by 3. Similarly, you can substitute the value of b here and find out what is the value of c. So simply substitute the value of c and we will see. Now that we have found out the value of b, which is equal to minus 1 by 3, we can substitute this in the equation for s raised to 1, because to the other side s raised to 1 is equal to 0. So we can equate the terms with s raised to 1 is equal to 0. Now we have b is equal to 1 by 3, which can also be substituted here to find out the value of c. So what is the equation here? 1 by 3 plus minus 2 by 3, because b is equal to minus 1 by 3, plus c is equal to 0. So what do you get c as? C is equal to 2 by 3 minus 1 by 3, or it is 1 by 3. Now that we got the value of a to be 1 by 3, b is also minus 1 by 3, and c to be 1 by 3 again. We are going to substitute these values in the equation that we have obtained by partial fraction expansion. That is a transfer function equation which is already here. In this equation we are going to substitute these values. So what will be the equation? Again, when we substitute these values here, you get it as T of s is equal to, take this equation here, a by s plus 2, right? So a can be substituted as 1 by 3 by s plus 2. Again, bs plus c can be written as minus 1 by 3 s plus c is 1 by 3 again by s square plus s plus 1. Now I have already told you the equation in this format has to be converted into s plus kind of poles terms. So s square plus s plus 1 is actually what? S square plus s plus 1 can be again factorized and written as what? This is actually s plus 1 by 2 s plus 1 by 2 the whole square plus 3 by 4. This should be right. Why? This s plus 1 by 2 the whole square is s square plus 2 into 1 by 2 into s, that is s, plus 1. 1 is actually what you get here is 1 by 4 plus 3 by 4, which together forms 1, right? This is actually s square plus 2 into 1 by 2 into s plus 1 by 4 plus again you have a 3 by 4 here, which forms our same old equation, that is s square plus s plus 3 plus 1 by 4 is actually 1, right? So there is nothing wrong in converting this equation into this format. There is nothing wrong in converting this equation into this format. So you can again rewrite this equation as 1 by 3 into s plus 2 minus 1 by 3 into s by, you can write this in this format, that is s plus 1 by 2 the whole square plus 3 by 4. This is actually s plus, again it is 1 by 3 into s plus 1 by 2 the whole square plus 3 by 4. So this is how you find the final equation or transfer function of this system. So we are done with the transfer function for this question. Thank you.